For the alcohol function group, the alcohol function group is contain OH or hydroxyl group. In the image is attached of a solitary carbon ring. This match of the typical structure of an alcohol. For amine function group is contain nitrogen atom bound to hydrogen or carbon atom, especially in the form NH2 or a primary amine. In the image, NH2 group is present in the structure next to the alcohol group. This fits the characteristic of a primary amine.
Next is about ether. The general formula of ether is ROR. Oxygen in the middle, connecting two alkyl groups. Ether is not that reactive, except combustion because of oxygen. The bond angle at oxygen is close to the theta-hydro angle, and we use ether as solvents for organic reaction. About aromatic hydrocarbon have 6 members bond together into a hexagonal ring, and the bonds between them alternate between single bond and double bond, so electron can move freely in a circle. And that's why this pi ring is much more stable than just a pi bond, and it's much less reactive than alkene and alkyne.
So I'll be presenting my part, which is the ester, the alkene, and the alkane functional group. So firstly, for the ester functional group, the carbonyl-carbon is sp2 hybridized and the bond angles are around 120 degrees, and it is bonded to one oxygen by a double bond and another one by a single bond. Esters are also functional groups of carboxylic acids, which means that they have the same molecular formula, but they have a different structural formula. And esters are formed by a reaction called esterification, which is when a carboxylic acid is reacted with an alcohol and water is created as a side product and eliminated. Esters are generally polar molecules, but they lack a hydrogen bonding between the molecules, which makes them reactive and volatile. And they also have the suffix ate. For example, ethanoate contains an ester. And these pictures are two of the ones that we found on our structure. And alkanes are a class of organic compounds which have carbon and hydrogens connected by covalent bonds, single covalent bonds, which makes them saturated hydrocarbons. And each carbon is sp3 hybridized, which has 4 sigma bonds, and they have a tetrahedral geometry with a 109.5 degree angle. And they are usually colorless, odorless, nonpolar, and they have a low reactivity, and they undergo combustion producing carbon dioxide and water, and they have a general formula of C and H2N plus 2. And lastly, for alkenes, they are unsaturated hydrocarbons which have at least one carbon-carbon double bond, and they consist of 1 sigma and 1 pi bond, and they have a trigonal planar geometry, which can lead to them having geometric isomerism because the 2 carbons are fixed and they cannot rotate. And they are nonpolar, insoluble in water, and they undergo addition reactions. And then they are the next homologous series after alkanes, and they have the general formula of C and H2N minus 2.